All right, we'll start off here on number 2. So number 1's kind of similar. So on number 2, I'm just going to isolate x here. So I'm going to subtract 8 from both sides. So that'll give me negative x is greater than or equal to negative 4. I don't flip the sign if I just subtract, but on my next step, I'm going to divide by negative 1. And multiplying or dividing by a negative is when we flip it. So I'm going to say x is greater than or equal to 4. We're going to have to do this on the number line and the interval notation. I'm going to go ahead and do the number line first. So we have 4 here, closed dot, and that's going to the left. And so I'm going to say that we are starting at negative infinity here and then stopping at 4. So interval notation always got to go in order. So the smallest one is going to be negative infinity in this case, and the biggest one's going to be 4. All right, next one here, we're just going to isolate x. I'm going to subtract 4x over to the left-hand side. I always like to isolate my variables on the left side of these inequalities. So I'm going to do that. That'll be negative 8. Okay, so then I'm going to subtract 5. So I get negative 10x is greater than or equal to negative 13. And then I'm going to divide by negative 10, which if you divide it by negative means you got to flip it. So less than or equal to 13 over 10. So on my number line here, I have 13 over 10. I got a closed dot, and it's going left. And so in interval notation, that's going to be negative infinity to 13 over 10. I got the parentheses around the negative infinity. That's always parentheses. And then the 13 over 10, since it's closed out as a bracket. All right, next up here, this is what we call a compound inequality. So we have to isolate x still, but when I subtract 5, I have to do that to what I call all 3 sides. So we have negative 10 is less than negative 2x is less than or equal to negative 7. And then I'm going to divide everything by negative 2. And since I'm dividing here, I'm going to flip all the signs. So this will become greater than, that'll be x, and then greater than or equal to positive 7 over 2. And so this kind of makes sense here because 7 over 2 is like 3.5 if you want to think of it like that. So that's certainly smaller than 5, so the alligators are opening up to 5. So on the number line, I got 7 over 2 right here. I got 5 right there. 7 over 2 is actually a closed dot, and then 5 is an open dot, so we have one of each. So it's going to be in the interval notation bracket 7 over 2, comma 5. And then the 5 will be a parentheses. All right, here we have our first nonlinear inequality. So this is kind of our new thing. So nonlinear inequality. The steps for this are, first of all, get one side equal to 0. All right, and actually I shouldn't say equal to 0. I should just say get 0 on one side. And then step 2 is factor. And then step 3 is number line. And then test points. So I'll talk about that last one. So you can see actually on this one, step 1 and 2 are already done. And so I'm going to go to the number line here and make on my number line, I'm going to put negative 5 and I'm going to put positive 4. Those are the x values that make these 0. I'm going to put closed dots on both of those because we have the or equals 2 here in the middle. And then I need to kind of test out some numbers in each little space to tell me whether it's going to come out positive or negative. So I'm going to test out over here first, and I'm going to test out x equals negative 6. I can test any number to the left of negative 5, so I just pick the next one, negative 6. And I'm going to plug it into these parentheses, and I'm just going to see if it comes out positive or negative. So negative 6 minus 4 is obviously negative, and the negative 6 plus 5 is obviously negative as well. But these are multiplying, so a negative times a negative is in fact a positive. In the middle here, I can pick any number. I'll go ahead and pick 0. Sounds easy to me. And so 0 minus 4 is, of course, negative. 0 plus 5 is positive, so this is negative. Since a negative times a positive is a negative. Lastly, we'll test out a number like x equals 5 out here, and that's going to make both of these parentheses positive, which will be positive. Now, next thing I notice is that if this is greater than or equal to 0, that means I want a positive number. Because think about the numbers that are greater than 0, and so I want all the numbers over here and over here. So my answer is going to be negative infinity to negative 5, and I'm going to close that with a bracket. We're going to do a union here, and then we'll go 4 to infinity. All right, next up I'm going to do number 7 here. So I'm going to first get one side to 0, so I'm going to subtract the 45. So 2x squared plus x minus 45 is greater than or equal to 0. And so now I'm going to factor this. So I'm going to do a times c here, so that'll be negative 90 and 1, so that'll be 10 and 9 with a negative 9. So I do need to split this up, so I'm going to say 2x squared plus 10x minus 9x minus 45 is greater than or equal to 0. Do my grouping. So 2x times x plus 5 minus 9 times x plus 5 is greater than or equal to 0. 2x minus 9 and x plus 5 is greater than or equal to 0. Now I need to go to the number line here. I'm going to have to put negative 5 for that one piece, and then positive 9 over 2 for the other. These are going to be closed dots here again. And then I need to do some test points, so I'm going to do x equals negative 6 over here. And that'll make the first parenthesis negative and the second parenthesis also negative, so that'll multiply to a positive. I always try x equals 0 there in the middle if it's possible, and that'll be a negative times a positive, which would be negative. And then I'll try over here, I'll just do like x equals, I don't know, 10 to be safe. So then that'll be a positive times a positive, so that'll be positive. Once again here, greater than or equal to 0 means I want positive, and so I'll go out here and over here, and so that'll give me my interval notation. All right, next up here on number 8, again, I'm going to get one side to 0, so I'm going to subtract 2x squared. I'm going to subtract 40 over to this side, and so that'll give me x squared minus 3x minus 40 is less than 0. So now I'll do my x here, so I got negative 40 and negative 3, it'll be negative 8 and positive 5. So I got x minus 8, x plus 5 is less than 0. So go to my number line here, I got negative 5, I got 8. And in this case, these will both be open dots because there's no line underneath here. And I'm going to go ahead and try out some numbers here. So I got x equals, let's do negative 6 here. And so that'll be a negative times a negative, and that'll be positive. X equals 0 I can use again, so it'll be negative times positive, which is negative. And then x equals 9, which will be a positive times a positive, which is, of course, positive. Now, in this case, because we want less than 0, I want the negative numbers. So that's the numbers right in the middle here. So it'll be from negative 5 to 8, not to infinity, to 8. Parentheses around those. All right, next up here, we'll go ahead and distribute this 4 in. So we get x squared is greater than 4x plus 32. And then I'll move everything over to the left side. And then I would go ahead and factor it and do my test points from there. All right, this one's already factored with 0 on one side, so that's nice. So I'm just going to go right to my number line and do my test points. So I got negative 5, I got positive 6, I got positive 9. I know that these are all closed dots here because there's a line and it's the or equals to. So now I'm going to test out something like x equals negative 6 here. So it's going to come out negative in the first one, negative in the second one, and negative in the third one. And I know 3 negatives multiply to give me a negative. I'm going to try x equals 0 in the middle. So that'll be positive, negative, negative. So that's going to be positive in here. I can try out like x equals 7. So x equals 7, so 7 plus 5 is, of course, positive. 7 minus 6 is positive, but 7 minus 9 is negative, so there you go. And then x equals 10 would give me all positives in there. And so that's obviously going to multiply to a positive. So this one, less than or equal to 0, means I want the negatives. And so I'm going to go in here and out there. So my answer will be negative infinity to negative 5. That'll be a bracket. Union 6 to 9. All right, next up, this one, I see we're like partially factored with a 0 over there. The only thing I would add is just put this as x plus 7, x minus 7. And then, all right, we'll go to the number line. So I'm going to put negative 7. I'm going to put 7. And then I do also need a 0 for that one because that's what makes that 0. So these will all be closed dots here. All right, so I'm going to try out x equals negative 8. And so if I do, this is actually a negative squared, and then this one will be a negative, and that one will be a negative as well. Now what this actually means is it's a positive times a negative, which will come out positive. So this squared I can already see, since it's going to be either a positive or a negative squared. No matter where I'm at, this is going to come out positive in this first one. I mean, this one will be a positive squared, but it's still going to come out positive. And this one as well will be a positive squared. So I'm just going to keep that in mind for this first piece here. And so I'm just going to have to test in the other one. So I'm going to do like x equals -6. So -6 will make this one positive, but that one negative. And so that's going to be a positive, positive, negative. And so one negative makes a negative. Next up, try out like x equals 1 here. So that's going to be positive, and 1 plus 7 is positive, 1 minus 7 is negative. And so this one will be negative also. And if I try x equals 8 here, that's going to be positive, 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 so it'll come out positive. So I want the negatives here because we're less than 0. And because this is connected with a closed dot there, I actually would combine these two intervals and just make it from -7 to 7. If it was combined with an open dot, I would have to keep those separate, but combined with a closed dot, I can combine them. All right, next up here, I would first isolate the absolute value by multiplying both sides by 2. So I'm going to say absolute value of x is greater than or equal to 2. And then you need to split this up once you isolate the absolute values. So you're going to say x is greater than or equal to 2, x is less than or equal to -2. And so I would just draw that on the number line. So -2 right here would be going that way. 2 right here would be going that way. And so I get -infinity to -2, bracket union, bracket 2, infinity. All right, number 18 here looks like the absolute value is already isolated, so I would split it up. So 3x plus 2 is less than 7. And then 3x plus 2, I would switch everything on the outside and nothing on the inside. So greater than or equal to, or sorry, just greater than -7. So then I would solve each of these. So then 3x is less than 5. And then 3x is greater than -9. And then we can divide both sides by 3. So x is less than 5 over 3. And then x is greater than -3. So we got -3 here, 5 over 3, both open dots. And I see that they're meeting in the middle because it's greater than the -3 but less than 5 over 3. So this one's just going to be -3 to 5 over 3. Sometimes they do this, they meet in the middle. Sometimes they shoot to the outsides. All right, next up here, we have to isolate the absolute value first. So I'm going to subtract 7. So negative absolute value of 2x plus 7 is less than or equal to -1. Then I need to divide by -1 to get rid of that negative. Oh, but I need to flip that sign since I divided by a negative. So it's going to be greater than or equal to 1. So now I would split it up like we did before. All right, next up, isolate the absolute value here. So I'll subtract 8, and then I get 7 times the absolute value of x plus 6 is greater than -1. Divide that by 7. Absolute value of x plus 6 is greater than -1 over 7. And I actually noticed right here, I'm not going to split it up because this is asking me when it's greater than a negative number. And so I'm going to say it's -infinity to infinity because an absolute value, no matter what x is, will be greater than a negative. All right, this one we're just trying to isolate x. I would just use all of the same rules I do kind of usually. I would just go ahead and distribute this. ABX minus AC is greater than or equal to BC. And then I would add the AC over. ABX is greater than or equal to AC plus BC in whatever order you want. I would just divide everything by AB. So I would say x is greater than or equal to BC plus AC over AB. That should work. I see that their answer, they factored a C out front of the top. I don't really like that, but if the first one doesn't work, then you can try that second one. They should both be okay, really. All right, I've got 2 rental car companies here. And it says, for what range of miles would plan B save you money? So I'm going to set this up here. So I want plan B to save me money. So plan B is really just 60 because we're talking about what range of miles. And then I would say I want that to be less than, not equal to, because I'm trying to save money here. And then this one would be 35 plus 0.1 m. Or you could use x if you want. All right, so now I would just isolate that. So I'm going to subtract 35. So I get 25 less than 0.1 m divided by 0.1. And so I would say m must be greater than 250. So in interval notation, I would say that's 250 to infinity. I know you can't really drive infinity miles, but we're saying just anything more than 250 and you'd be saving money. You want plan B. All right, this next one here, it looks like a word problem, but they're really giving me the equation here. And they're saying, when will the ball be at least 32 feet above the ground? So I want the height. Let's see. So I want my equation to be greater than or equal to 32. So then I'm going to get one side to 0. Looks like this is a nonlinear inequality. So I'm going to, I'm actually going to move everything over to the other side here. So I'm going to add 16t squared. I'm going to subtract 128, subtract 16t. So that'll give me 0, greater than or equal to 16t squared minus 16t. And I have to subtract the 128 here. That'll be negative 96. I see that these all divide by 16, so I'm going to go ahead and do that right away. So I'm going to say 0 is greater than or equal to t squared minus t minus 6. So we'll go ahead and factor here. Let's see. Negative 6, negative 1 would be negative 3 and positive 2. So t minus 3, t plus 2. Now, remember that this is a nonlinear inequality, so we're going to have to do a number line, and we're going to have to do test points. We got negative 2, and we got 3. Let's say they're both closed dots. And so I'm going to try out here, x equals negative 3. In the factored form would be negative 3 minus 3 is negative, negative 3 plus 2 is negative. So this comes out positive. If I try x equals 0, it'll be a negative times a positive. So that'll be a negative. And then x equals 4 would be a positive times a positive, so that would be positive. All right, now this one's a little tricky because we're reading it backwards, but remember that the way this is pointing, I'm actually wanting a negative here because I'm saying my expression should be less than 0. And so I want the space in the middle from negative 2 to 3. However, key issue on this one, time can't be negative. And so I am actually going to cut this off at 0 just for the context of this problem and say my answer is 0 to 3. The math tells me it's negative 2 to 3, but the time being negative is impossible, so I'm going to start it at 0. All right, next up here they gave us me the revenue and the cost, and so you use this formula really quick, so I know that my profit is going to equal 21x minus 2,800. Oh, and I'm going to have to distribute this negative here, so I'm going to do that. All right. And so to simplify that, I'm going to call this negative 10x, negative 2,800, and a negative 0.002x squared. And we'll go ahead and combine like terms here. So I get negative 0.002x squared plus 11x minus 2,800. That's our profit. And then we want our profit to be at least, so I want it to be greater than or equal to 2,200. So I want 2,200 to be less than my profit. So I'm going to plug that in over there. All right. And then we'll move this over, get that side to 0. All right, now I really don't like that 0.002, so I'm actually going to divide everything by negative 0.002. Get rid of that. Now I do have to divide this by negative 0.002 as well, which seems like it may be insignificant, but it's actually going to flip the sign here. like so, because I am dividing by negative. I'm going to use a calculator for these other ones here. So 11 divided by 0.002 be 5,500. I'm going to switch that to a negative, and then this last one will actually switch to a positive. And that's going to be 2.5 million. All right, so I'm going to go ahead and use a diamond on this. So we're going to 2.5 million. And let's see, we are trying to add to negative 5,500. So I actually think that's going to, let me check 500 and 5,000. I think that'll work. They usually kind of make this a little bit easy here, and I see that it does. So those are my numbers. So I get 0 is greater than or equal to x minus 500, x minus 5,000. I do have to go to my number line here, so I need 500 and 5,000. I got to test this out in the factored form. So I'm going to try out x equals 0 here. That's going to be a negative times a negative, so that's positive. Try out x equals 1,000. And that'll be a negative times, actually no, that'll be a positive times a negative, so that's negative. And I'll try x equals 6,000, which will be a positive and a positive, which is positive. Now, this one, the way it's pointing means I want negatives, because kind of need to read that backwards. And so I'm going to go from 500 to 5,000. All right, next up here, we're going to factor out the common factor. And so the smallest power of x is negative 1/2. And then that one's going to go away. And then remember, it's going to increase that one to 1, and it'll increase this one to 2. And so I would rewrite it like that, and then I would rearrange it. And then I would go ahead and use the diamond there. All right, next up here, we got to do some factoring. I'm going to use the u substitution. I'm going to let u equal x squared plus 5. And I'll use another one like y for x minus 2. But I'm going to rewrite this. I'm going to combine these pieces and call it 10x times u to the 4th and then y to the 4th plus 4 times u to the 5th, y to the 3rd. So I'm going to GCF here. I'm going to GCF a 2. I'll do u to the 4th. I'll do y to the 3rd. So that'll give me 5x y plus 2u. And so now I'm ready to plug back in. And then this is x minus 2 squared. And then here I have 5x, and I got to use a bracket here. And this will be kind of the big part of the problem, is I have to distribute that into x minus 2, and then I'm going to distribute 2 into x squared plus 5. So I'm going to work on that over here. So this will be 5x squared minus 10x plus 2x squared plus 10x. Nope, that's just plus 10. All right, so now I'll combine like terms. So that's going to give me 7x squared minus 10x plus 10. And then over here I got the rest of this stuff that I didn't write. And oh, that's third power actually. Okay, and I'm done. All right, next one here, I'm really going to think of this as x minus 12x to the 1/2 plus 32. And the reason I'm going to do that is now I can see that if it's, if it's the first power and then the 1/2 power, I can still factor it. And so it's going to be 8 and 4. So I get x to the 1/2 minus 8, and x to the 1/2 minus 4 equals 0. So I could say x to the 1/2 equals 8, x to the 1/2 equals 4. And then I can square both sides here to get rid of that 1/2. If you can think of it as a square root, I'm squaring to get rid of, so that's 64. It's not a plus or minus because I squared it. I didn't square root it. And then I square both sides here, and x equals 16. All right, last up here I see I have fractional exponents. There's no GCF, but the second one is the half of the first one, so I can just do a diamond here. So I get let's see, -6, -3. So I get x to the 2/3 minus 6, x to the 2/3 minus 3 equals 0. So x to the 2/3 equals 6, x to the 2/3 equals 3. And then I can raise both of these to the 3/2 power. right? And so, let's see. So that would be 3 to the third power with a square root equals x. But since I created that square root, I'm going to need the plus or minus. And instead of calling that 27, I'm just going to think of that as 3 times 3 times 3. And since that's in a square root, I can really just take, I have kind of twins here. They can go outside, and I get plus or minus 3 radical 3. Or if you want to think of that as like a 9, we're taking the square root of 9, and so that's a 3 on the outside. So I can actually do the same thing over here, where I think of this as the plus or minus the square root of 6 times 6 times 6, and I can just call that plus or minus 6 rad 6.